Alright student, let us start today's topic, that is differential equation. So we'll be covering differential equation topic in two lectures, that is lecture 1 and lecture 2, once for the today's class, and the other we'll cover and end it tomorrow. Very important chapter from both the ends, that is your board as well as your entrance examinations, because it is something which will cover marks at both the levels. So and one important thing is that it is given at a very good level at your NCERT textbook also. So do keep in mind that you need to do NCERT textbook as well if you want to be good at differential equation, because it's a very good basic book if you want to have a base level work being done for this chapter. What I will be covering in this particular chapter, as per se your IIT JEE Mains syllabus, is that we'll talk about order and degree, formation of differential equation, solution of differential equation, and the three particular categories that we have to solve: variable, separable, homogeneous, linear, LD. We'll also cover something called exact forms, which is something you can say a trick method. Then we'll cover orthogonal trajectory of a curve, again a very simple thing, and we'll also do their geometrical application. So these three things are something which are not in, you will not find in your NCERT textbooks. Apart from that, everything will be in the NCERT portion. Okay, so we'll try to in fact cover in today's class order, formation, and the solution of these two forms, and the rest we'll do it in the tomorrow's lecture. That is a target that I have kept in mind. Okay, so let's start today's topic. Okay, so let us start with the definitions of basic terms, that is what is differential equation. So if we, and I'll be writing differential equation in a short form as DE, right? So don't get confused, what is DE? DE is nothing but differential equation. So what is a DE? So any equation written in terms of x, y, dy by dx, or the further derivatives of y with respect to x, something like this, dx square, dqy by dx cube, so on. If I say so, a equation in terms of all these parameters is known as differential equation, right? But the important necessity over here is that you should, what you should have is that you should have the differential coefficient term necessary. Differential coefficient term, right? What do you mean by differential coefficient term? Is that if you want to call any equation a differential equation, then for example, this term contains x and y, but this does not contain dy by dx or d2y by dx. So I will not call this as a DE, though this is an equation. So for a differential equation, the differential coefficient term is a must. It could be anything. Let's say dy by dx. Okay, so this is completely fine. You can instead just say that, sir, I will write dy by dx is equal to 1. There is no y, individual y, that is acceptable. You can say, sir, I'll say d2y by dx square equal to 5. This is completely acceptable, because as long as you have dy by dx or d2y by dx square, I'll call it as a D. Two other prominent terms that we people have to do is the order and the degree. Order of the differential equation and the degree of the differential equation. So order, as the name, it is written on your screen, it is the highest order derivative. Mind the spelling errors over here. So order is the highest order derivative. So if it is dy by dx in the equation, then order is 1. If you have d2y by dx square, order is 2. Similarly, and degree is the power of the highest order derivative. But there is a problem with the degree, right? It is the highest degree of the highest order term is known as the degree, right? Highest order. But whatever you have written in the equation has to be free from radicals and fractions as far as differential coefficients are concerned. So what do you mean by this? That it should be polynomial in terms of differential coefficient. What do I mean is that the equation that you have written should be polynomial in terms of differential coefficient. This is a layman definition that I can tell you. Differential coefficient. So that means if there is any differential coefficient written, then it should, the power of that differential coefficient should be a positive integer. If it is radical, fraction, negative, I cannot talk about the degree then. Okay, so this is what we are going to talk about in the questions that are there on your screen. So first question that we are going to take is, the first says that d2y by dx square is equal to y times dy by dx raised to power 6 raised to power 1 by 4. So we are asked to find order and degree. Here, if you see in this question, the highest derivative term is second derivative. This is the second derivative, right? And this is the first derivative. Okay, so what is the order then? Order is the highest order. The highest order is second order, right? Can you see this? So we can easily see that order of this particular equation is 2. Okay, and if I ask you the degree, then degree, we know that degree is nothing but power of the highest order term. So order term is this, and its power is nothing but 1. So the answer to the degree should be 1. So if you answer this, then your answer is wrong. Degree is not equal to 1. So let's understand why degree is not equal to 1. I told you that for degree, the differential coefficient term, right, should have all integer powers, positive integer powers, right? So this has power 1. But what about this particular bracket on the right hand side? It is dy by dx, not a problem, it has power 6. So do not get confused when I talk about order by seeing degree. You do not want the power, that highest power is the order. So for order, highest derivative is the order. But if you see that here power is 1 by 4. So actually here you have a coefficient, differential coefficient, whose power is a fraction. So first of all, you need to solve this by taking, yes, what you will do? Yes, you will take power 4 on both sides. Now if I see this problem, now I can say that all the differential coefficients have integer power. So the power of this is 4 and the power of this is 6, which is completely natural number. So the degree of this particular equation is not 1, you will say 4. So the answer that we are looking for in this is order 2, degree 4. Got it? Let's take the other problem. It says y is equal to, so if y is equal to something of this is given, now again the derivatives are not written in the polynomial format. They are e raised to power x, right? E raised to power function. So what we will do, we'll take log on both sides. So log y is equal to, so this I'm taking log with base e, right? Assuming that. So now I can say this is the thing which is written. Now it becomes, this particular equation becomes polynomial in terms of what? I am not talking about polynomial in terms of x and y, but in terms of differential coefficients, right? Why? Because see, dy by dx has power 1, d2y by dx square has power 1. So which is the highest order term? Yes, so the second derivative is the highest order and its power is perfect. So for this question also, order you will say is 2 and the degree that you are going to say is 1. Okay, let's take this problem now. Now the problem in this is that you have sine, right? Sine. So sine does not make dy by dx, which is written inside it, as the polynomial. So you will not say something that sine x is a polynomial, right? It is not a polynomial. But I can make it polynomial by doing sine inverse, right? If I write something like this and say sine inverse y, then now this particular LHS again becomes polynomial, right? It becomes polynomial again in terms of differential coefficient. So again I can say order and degree will be defined. What is the order? Again, order is the highest degree coefficient, that is 2. What is its power given? Yes, power is 1. So order 2, degree 1. So this is how you actually solve order and degree problems. Okay, now let's take this one example here. Here again it is e raised to power d3y by dx cube, and let me take it over to the other side. It is x, right? So if somebody asks you what is order, order is always defined. So if I have to talk about order, remember that order is always defined. Order is always defined. So you cannot say that I cannot tell you the order of a particular. So order is always defined. So that is not a problem. Okay. So what we need to check here is the degree. So for example here, the answer to the order is, what is order? Order is 3. Why? Because the highest derivative that you people have is 3, right? But for degree we needed polynomial in terms of the differential coefficient. So let's try and make a polynomial. So here this, if you see this coefficient, this is written in a polynomial format. Why? Because it has coefficient x and something like this, but this is not written in the polynomial format. In fact, here the differential coefficient is in the exponential format. So this is not a polynomial. So we know that we need, if we want to convert exponential into a polynomial, we can take a log. So if I take ln on both sides, right? Ln on both sides. Okay. If I take this on both sides, so what you can say then? It will become d3y by dx cube is equal to ln, what this will become? Yes. But still the problem is not solved. Why? Because now this now reduces to a polynomial, but this becomes a logarithmic function rather than the polynomial. We want that every differential coefficient term should be expressed as a polynomial, right? So I would say either this would be polynomial or this would be polynomial, but both cannot be written in a polynomial format. So here you will say degree cannot be defined or degree is not defined, right? Though the order is defined in this particular question, but I would say that degree is not defined. Okay, I hope the question is clear. Let's take the other one. Here in this problem you have given dy by dx plus y is equal to 1 upon dy by dx, right? And since dy by dx can be written as dy by dx raised to power minus 1, so this is now not in the polynomial format. So you can immediately say that order is 1. That is not a problem, right? Order is 1 because the highest derivative that is available in this equation is 1. But for degree, what you will do, first of all, arrange this into polynomial. This is not polynomial, 1 by x. So just consider something like this 1 by x. 1 by x is not a polynomial. For polynomial, the degree of x or the power of x should be positive or at max 0. So I would say I will cross multiply this. So if I cross multiply this, what you people will get is dy by dx square y dy by dx is equal to 1. So now this is polynomial in terms of differential coefficient, where order is 1, but now you can say, sir, degree is 2 because the maximum power that you are getting is 2 here. Let's take this particular problem over here. It says dy by dx, so dy by dx raised to power 1 by 2 plus y whole raised to power 2 is equal to, so what is the order? Can you see the order? Order is straight away. So the highest derivative is 2. So order is nothing but 2. That we can immediately tell you. But you cannot say that degree is 1 right now here, because what is happening here? Here if you see very properly that this is something, a power which is fractional. We cannot leave a differential coefficient with a fractional power if we are talking about degree. So we want to make this integer. So let's square it out. So if we square, what will happen? So yes, it will become dy by dx plus y square plus 2y dy by dx raised to power 1 by 2, right? This is what you will get actually. Okay, got it? But is it still in a polynomial form? Here the problem again lies that you are getting a power which is 1 by 2. So how you will remove this? That is very simple again. So I will rearrange this to write something like this, d2y by dx square, right? And let me take a negative. So can I write something like this? I have taken these two terms over the right hand side. Now if I square, if you square, so what you will get? So if you square, this 1 by 2 will be removed, and this complete thing would be, let me just change the pen to highlight. So this will be something like this, right? Can I say so? Okay, so if this is the case, then this will also, if this complete is also square, then this will also become polynomial. So now this becomes what? Polynomial, right? Now what is the degree then? Yes, if you square, whatever you will square, so this is basically square of 3 terms. I don't know what it is, but I know that the maximum power that d2y by dx square will get is this 2. So I will say nothing but degree is 2. Now the degree is defined. That's not a problem. So order 2, degree 2 also. So this is how you actually have to solve order and degree problems. Just keep in mind that order is always defined. For degree, you need to find polynomial in terms of differential coefficients. What do you mean by polynomial is that the power of each differential coefficient, whether it is dy by dx, d2y by dx, dqy by dx cube, has to be positive integer. Alright, otherwise you will say that degree is not defined if you cannot do so. Okay, now let's look at the other aspect of this chapter, that is formation of differential equations. So what you will be expected to do in formation of DE is that some constraints will be given to you in the question, and you will now try and form the differential equation out of it. Constraint will be given in the English language, and then you will try to form DE. So I'll take an example and then I'll show you what are the steps involved in formation of DE. So form a differential equation of family of circles touching x-axis at origin. We need to find family of circles touching x-axis at origin, right? So first of all, if you want to be very good at formation of D, even at the board level, I am again recommending just go through the basics of circle, parabola and ellipse, right? because in board level you will find problems which are based on their basic geometry, right? Basic geometry, not the entire chapters, but the basic geometry, how they are formed, what are their special cases. This is what I meant by this. So family of circles touching x-axis. So if a circle touches x-axis, so what is the condition that we people know about this? I have taught you in the circles topic also, this particular thing, and that is the reason we did class 11 topics a bit earlier. So if it touches x-axis, let's say the center is h comma k, right? Let me take center, this is the center. So if it touches the x-axis at origin, this is also given, I'll talk about this also. So if touching x-axis is the only condition, then h comma is the center, then radius is nothing but the ordinate, that is k. So radius is not a variable. So if I talk about the general equation of a circle, that is x minus y plus this should be the actually the case of a circle. So why we are doing this is I am explaining you the concept in a way. How many parameters are there? Can you tell me parameters in this particular equation? I'm not talking about the variables. I know that the variables are 2 x and y. So parameters are 3. What are those parameters? H, k and r, right? So there are 3 parameters, and actually we do not call them parameters, we call them arbitrary constant, right? Arbitrary constant. Why? As an you can just understand them because they are constants but for a particular equation, but they can change their value. That is why we call them parameters also. So there are 3 arbitrary constants. If I write the equation of circle like this, so for formation of, just remember the rule now, for formation of DE, right, the rule says order should be equal to number of arbitrary constant. I'll write arbitrary constant AC. So number of arbitrary constant should give you the order. So that means if there are 3 arbitrary constant, that means you need to differentiate it thrice. That is why when you will get dy by q by dx cube, right? So our whole target in formation of D is to figure out how many arbitrary constants are there. And if you get this wrong, obviously the entire question will be wrong. So it touches x-axis, right? It touches x-axis, then h comma k is the center, then the radius will be k. So now can you see that there are, up till this step, there is 2 arbitrary constant. Why? Because radius is no longer a variable. Radius is itself k, because these 2 are parameters and this is nothing but k itself. Now this is also given that it touches at origin, right? It touches at origin. So that implies y-axis is normal. Just think of it. Why I'm saying y-axis is normal? Because it is given that x-axis is tangent, right? And that too tangent at 0, 0. So that means y-axis is normal. Normal passes through, exactly, normal passes through center of the circle. So h here is nothing but 0. So in fact it reduces only to 1 arbitrary constant. That is, now what is given to you is that center of the circle is 0, k and the radius is equal to k. So how many arbitrary constants here? 1 arbitrary constant. So this implies that order should be equal to 1. Whatever you do, if the order is not 1, either it is less than 1 or it is greater than 1, they are both wrong. It has to be exactly equal to 1. Remember this step. Okay, so what I will do now, I'll try and form the equation first of all. So equation can be written as x minus 0 whole square plus y minus k whole square is equal to k square, right? So this comes out to be y plus something like this. Now you want to eliminate, so the next target, so this is step 1, you need to figure out that what is the order, right? The step 2 of formation of equation is, step 2 is form DE, form differential equation with this particular order, which is independent of arbitrary constant. Another important stuff, independent of arbitrary constant, right? Then it will be differential equation. So now your target is to eliminate k from this, and you can differentiate only once. Keep this in mind. So what you can do, so just if you just explore this, it is x square plus y square plus k square minus 2yk equal to k square. And if you see, this k square gets cancelled out, so you can reduce this actually to x square plus y square is equal to 2y k. And now if you differentiate, what you will get? If I differentiate, let's change the pen again. So if you differentiate, this is 2x plus 2y dy by dx is equal to 2k dy by dx. But if you say here k is still there, you have not eliminated k, you have actually y, because you can find the value of k from here. So it will be k can be written as x square plus y square by 2y, and now you can substitute this value of k here, right? So the last equation that you people will get will be a differential equation where the order is 1. Why order is 1? Because you have only dy by dx, right? And there is no k, that is no parameter or no arbitrary constant. So the form DE which is independent of arbitrary constant. This is how you solve this question. Okay, now let's apply the formation of DE in other question. This is form the differential equation of family of parabolas with focus at origin. So now the focus is origin, right? Focus is given to be origin. And the axis of symmetry, symmetry is given to be x-axis only. It is said that along the x-axis, it could have been parallel to x-axis, then the question would have become a bit different and a bit difficult also, but it remains that it is x-axis only. Now compare this particular strength with our y square equal to 4ax. For y square equal to 4ax, the vertex used to be at origin and the focus was what? A comma 0. Now that is why I was saying that you should be very thorough with the geometry of basic shapes of circle and parabola. Why? Now see. Now this is given that this is 0 comma 0. The focus is 0 comma 0. S. We know that distance between vertex and focus is nothing but a, that you use here. So if this is the case, now if you know about geometry of this, I can say y square equal to 4a x plus a is the equation of parabola. Now this is what you have to remember from the parabola that we just did a week or 2 weeks back. So if you see this, the vertex, if I have given you this, the vertex you people would have said is minus a comma 0, which is happening here. So don't worry. So this is actually the equation that you will use to form the DE. How many arbitrary constants here? So arbitrary constant is nothing but 1 here. So this implies order is also 1. This implies the maximum time that you can differentiate only once. This is what is meant by this. If I start differentiating, so I will get what? 2 dy by dx, right, is equal to 4a. Now our target, the next step is to then remove arbitrary constants. So here you still have arbitrary constant. Do not do the error of differentiating again. So I have seen some students who differentiate this again, right? And they happily then say that, sir, I have done the question like this. They will differentiate like this and then they will say, sir, my question is over and this is the answer that I am getting. But this is completely wrong, because what is the order here? The order is 2, order should be 1. So that is why it is wrong. So what we will do, we cannot differentiate from now, this step onward. So what we are going to do is, we are going to put the value of 4a again here. So if I do this step, what you will get, let's see, y square is equal to, put the value of 4 is 2y dy by dx x plus a. So a is nothing but y by 2 dy by dx. And if you see in this problem, there is no arbitrary constant and it is polynomial in terms of differential coefficient. This is your answer. So just simply solve this to get this particular value, dy by dx plus y square dy by dx, and this will be nothing but whole square. So we know that the order of this is nothing but 1, but now interestingly the degree also comes out to be not 1 but 2. This is the term which will be used for degree. Highest power is 2. This is the answer that we were looking for. So some students can also argue, sir, that the parabola can be in this particular shape, which is completely fine. So if we want to talk about, then this will be the focus and the vertex will be a comma 0, and the standard shape will be then of y square equal to minus 4ax type. So the parabola over here will be written as y square is equal to minus 4a x minus a, right? So you can solve by this also and you can solve by this also. In fact, they are one and the same thing. This is happening when a is negative. This was happening when a was positive. So you just replace a by minus a, you will automatically get this. So no need to solve two different cases. So what I have to tell you is that this particular case will only fetch you the answer. The answer to both of them will be the same. You can check it at your home. Okay, now let's take the other problem. It says find differential equation of the system of parabolas, which is given by this. Now parabola is y square equal to 4a x minus b, right? So how many arbitrary constants are there? So this time round there are two arbitrary constants. So that means I will need to what you can say about the order is 2. So that means you should differentiate twice. Differentiate twice, right? This is the requirement now. This is the basic requirement. You cannot say that I'll differentiate once or I'll differentiate two. You have to differentiate it twice. So if you differentiate, so what will become 2y dy by dx is equal to 4a, right? And if you again differentiate, what you will get, you can say that y dy by dx is equal to 2a. Your target is to find equation which has order 2 plus it has no arbitrary constants. This is what you want to find. So what you will get is dy by dx square plus y into d2y by dx square is equal to 0. So if you check this particular case here the degree is what? Degree is 1. Why degree is 1? Because for degree you will take the highest order term. Highest order term is nothing but d2y by dx square, and there is no arbitrary constants. This is the answer we were looking for. In fact, you can also write this one as y1 square plus y2. So y2 is nothing but the second order and y1 is first order derivative. So this is the answer we're looking for. In fact, it is much more easy than what you people have earlier done. Let's take the other one. It says you have to find differential equation when this is the relation which is given to you. Y is equal to a into e raised to power x plus b into e raised to power minus x plus x square, where a and b are arbitrary constants. So two arbitrary constants, two ACs. This implies order is 2, right? This is what we will use. So let's start differentiating this term, and we know that we have to differentiate twice. Dy by dx, or I can say y1 is equal to a e raised to power x minus b raised to power minus x plus 2x. Don't just worry, just keep on differentiating. Y2 will be a e raised to power x. This will become again plus, this is minus x plus 2. So now you can see that we have reached this double derivative. This is, after this we cannot differentiate more because the order is 2. So this implies differentiate twice, right? This is what we have learned earlier also. So whatever has the answer has to be here, but still you are getting a and b. Now just compare it with the original one. Original equation was a e raised to power x plus b into e raised to power minus x plus x square, and you are getting this particular term again. Can I say a e raised to power x plus b e raised to power minus x is nothing but y minus x square? Just put this value over here. So this becomes y2 is equal to y minus x square plus 2, and now if you see, this is a differential equation which is not having any arbitrary constant. This is your answer. So you can say d2y by dx square is equal to y minus x square plus 2 is the answer, where obviously the order is 2 and the degree is 1. This is how you solve this particular question. So the next problem is asking find the order of differential equation of all circles of given radius a. So you are not asked to find the differential equation, you just have to find the order. So what is given about the circle? For circle, what is given? That it has a fixed radius, that is equal to a. So that means it is not an arbitrary constant anymore, right? So what you can say is, if I start writing the equation of circle, that is something like this, equal to a square. So how many arbitrary constants are there in this particular term? Arbitrary constants. So here the arbitrary constants are just two. What are those? They are h and k. A is not the arbitrary constant because it is given, it is the in the statement itself. So 2 is the number of arbitrary constants, simply order is nothing but equal to 2. Now let's take the other problem. It says find the order of this particular differential equation where this is the case that y is equal to. So c1 sine of x plus c2 plus c3 plus c4 cos x plus c5 times e raised to power x plus c6. So at the first moment it looks like how many arbitrary constants? Can you tell me how many arbitrary constants are there? So the arbitrary constant looks like to be 6. So the immediate answer that you people can answer is order is equal to 6. Okay, but the answer is not 6. That's the beauty of this question. So that's the reason I have taken this. The order is not 6. So if you answer the 6, it is wrong. So now let's see how I will write this particular question now. And you people have already done this something similar to in your indefinite integration. So this C1 and this C2 are completely separate identity. They are nowhere related. So I cannot connect them. But this C3 plus C4 can be combined to write a new constant that is, let's say C3 dash, or let's me call it at let's say C3 dash, or let's say we'll change the name to just C3. Okay, just C3. Okay, I'll combine this to just form C3 because two constants can add up to give you only a single constant. So this is cos x, right? Now if you see, this question now reduces to something like this. Now how many arbitrary constants? Now yes, now the answer should look like this answer is 5. That implies order is 5. But if you say order is 5, then again this is wrong. Why this is wrong? Now let's see. The twist in this question is that this last particular component c5 e raised to power x plus c6, this can be further resolved as c5 e raised to power x into e raised to power c6. What is c5? Now you can see that here this is one of the constants and this is the other constant and this is e raised to power x. Product of two constants will again give you a single constant and this is c5 e raised to power x. So the whole equation can now be written as something like this. C2, so two constants, c3 cos x, third constant, and this c5 e raised to power x. So how many arbitrary constants? So arbitrary constants are nothing but 4 in this case, right? So since 4 is there, so order is also 4. So neither 6 nor 5, answer is 4. I hope you get the point what I am trying to put out here. Let's look at the third component of this chapter, that is solution of DE. So before I move further, I'll just explain you that what is the flow of the chapter. The flow of the chapter is that either you will form the question formation of DE, you will do, right, or you will do what? Solution of DE. Solution of DE. And these two processes are interconvertible. So from solution you will do formation, formation you will do solution. So what do you mean by this? Either you will go for the equation and then try and pull up its D. So this arrow is representing the formation part, or what you will be doing is that you will be given D and now you will be forming the equation. So this blue part is your solution and this green channel is your formation. So the chapter is entirely based on these two things, equation to DE or DE to equation. So now we are going to do that. You are given a DE and you are now trying to find its equation. That is called solution. Solutions can be of two types, general solution and particular solution. In fact, there are 3 types. There is another called singular solution, but we do singular solution only for advanced level. So I'll skip this for the time being. So general solution, what do you mean by general solution over here is that relation in terms of x and y, which you obtain by obviously what you people will have to do here from differential equation to the equation, that you will need to integrate. So after integrating, you will definitely get what? Arbitrary constant. So if the equation has number of arbitrary constants equal to your order, right, this equation is known as general equation, right? Very similar to what we just did in the formation of equation. But if there is no arbitrary constant or less than the order, right? Number of arbitrary constant is no arbitrary constant or they are even less than the order, then that means you have some specific value which has eliminated some of the arbitrary constants or have removed all of the arbitrary constant. So then it will be called a particular solution. So for example, the function could look like y equal to sin x plus c. So this is the constant c. But if you say, sir, it is y equal to sin x plus 1, right? If you differentiate both of them, dy by dx for both of them will be same, right? So what is the dy by dx? We know that dy by dx this here also, and dy by dx is equal to cos x also. So the differential equation for both the equations is remaining the same, but the answers are different. So here the c value is very specific. C is 1. That is why we call this as the particular solution, and I'll call this as the general solution. This is the difference between both of them. Okay. In fact, you will also find these kind of problems given to in your NCERT as initial value problems. I'll just show you that how this initial value problem works in this particular cases. So let's talk about methods to solve D. So there are three methods that you people have to solve. So one is the variable separable form. Variable separable. I'll just show you what you mean by variable separable form. Okay. Other is that you will have to do is homogeneous form. Homogeneous. And the third one that you people have to do is linear differential equation. So these are the three methods that you people will apply in solving a DE. Alright, and we'll go by step and do all three of them. In fact, there is further category of all of them is that a question might not be directly variable separable. So a category will be reducible to variable separable, that is VS. Also in homogeneous, we can have a question which is reducible to homogeneous, though this is not asked at JEE Mains level, right? So we will not do this. And here also you can have reducible to LDE. I'll call linear differential as LDE in short forms, right? So basically this is the workflow of how to solve a differential equation. So what is variable separable? If we talk about, so dy by dx can be written as a separate function of x and a separate function of y. And how you can solve them? You can separately solve this and you can separately solve this. Okay, and then you just integrate. This is what is variable separable. In homogeneous, we'll talk. Okay, so let's do one thing. We'll go step by step. So this is what you people have to understand of variable separable, and let's first of all do variable separable form. So okay, now let's start with the variable separable form. So for variable separable form, it is very simple that what you have to do is that you want to form dy by dx, where you can write separately here, right? As the name suggests, you want to write separately function of x and function of y. Okay, so that is the target of this particular method. So this function could be any, it could be in the denominator and it could be in the numerator. That is completely up to you. So basically explicit functions. Remember we did this in differentiation also, explicit functions and implicit functions. So you need explicit functions here which can be separated in x and y. So for example, let's take this particular problem over here. So it is dy by dx is equal to, I can say 2 tan inverse x plus x upon 1 plus x square, right? Okay, I have done error. This is not t, this is yes x. So can you see, this is a very simple problem that I have taken just to highlight that how you separate them. So this is completely a function of x. So I can now just write this with dx, right? 1 plus x square dx, and now I'll just integrate. Okay, so if you integrate, this is nothing but y. For this integral, what you will do, can you see that this is also a very simple problem? Why? Because let's assume 2 tan inverse x plus 1 to be t. Is it right? No, obviously this is not right. What we will do here is we'll separate them in two terms. So if we separate, what will happen? Let's see, 2 tan inverse x plus 1, something like this, and plus x upon 1 plus x squared. Now you can simply do the step, because now rather than this, what we will do for this, we will put tan inverse x equal to t, right, for which this dx upon this will get converted to then the answer would be what? So this entire stuff, what this entire stuff will become 2t dt, and you can similarly see that this is nothing but derivative. So uh, in this chapter involves a lot of indefinite, and that is why I was saying in indefinite topic that indefinite has lost its value. Why? Because indefinite could be asked very easily in this particular chapter. See, this becomes 1 plus x square, right, and plus c can be added. So it is nothing, it will give you t square plus this. And now what is the value of t square? We know the value of t square, we put t as this, so this answer, complete answer, will become tan inverse x square plus 1 by 2 ln 1 plus x square plus c. Now remember that here also you will get integration constant, and here you will also get integration constant. Two constants added will give you a particular constant. So this is the answer we were looking for, right? Clear? So this is how you have to solve variable separable form. Let's take other problem on variable separable form. It is given log dy by dx equal to ax plus by. Now we want to find the equation which we can solve by this. So what we will do, we again try to do the variable separable form. It can be written as log can be then converted into exponential form, right? And it looks like that this is not a variable separable form, but yes, it is indeed a variable separable form by doing this very simple step. Alright, you can just do that. This is nothing but equal to this, and now these two are explicit functions because x is separate and y is separate. So just take the component of y with dy and the component of x with x, right? This is what you will solve, and this is now completely solvable. Just integrate e raised to power minus by dy, and you will also integrate what? E raised to power ax dx. So what will be the answer for this one? It will be e raised to power minus by minus b is equal to e raised to power ax by a plus c. Remember, we just need to add c on one of the sides. Either you can add here or you can add to the right hand side. This is one and the same thing. Alright, and I hope now the question is, that's it, very simple question. Okay, let's take other problem quickly then. This is the problem here, and the problem with this one is that this is completely big quantity which can be very simply simplified. Can you see that what I am doing? I have taken y square common from the last two terms, and if I see this is also coming common, so I can say this is nothing but 1 plus x square into 1 plus y square, and this one in the under root. So this is the actual question that is being asked of you. Now if you see, we want to do something of the variable separable form. So what I will say that dy by dx, let's say xy is here, and here I can write as, and I can split the under roots now. Can you see this is explicit in terms of x and y? X function is separate, y is separate, and now I hope the question is quite much clear to you all. This is y square. Keep the y term here, right? I'll send this x over here, so this becomes what? Minus of 1 plus x square under root by x dx. And now you just want to integrate because it is again variable separable form. And again you can say this now question becomes pure question of integral. You can easily solve this by putting 1 plus y square equal to t square. How you are going to solve this particular question? Let's say if I ask you, I2 is your integral minus you can take outside 1 plus x square by x dx. How you will resolve this particular stuff now? Okay, so let's start doing this particular question then. So what I'll do, I'll put 1 plus x square equal to t. So that is what I will do. So this becomes 2x tx is equal to 2t dt, or I can say dx is equal to t by x dt. That is what I'll substitute. So I2 then reduces to minus of, this becomes what? Integral of t into, there is already a x here, right? T by x. Dx has been converted to t by x dx, and this reduces to entirely t square by x square. X square can be written as t square minus 1. Now I guess you can do the question, right? So just add and subtract what? Plus 1 and minus 1. So I'll do minus 1 plus 1 in the numerator to solve this particular problem, and I hope now you can solve this, right? Okay, so I'm leaving this portion to you. Just solve and put the value here and you will solve this. Now let's take an interesting problem which is actually from your NCERT, and these are word problems which are very important, and I would say the most relevant in terms of your life, relevant in terms of real scenario, relevant in real scenarios. This is how actually the things are done which are asked in this question. So very relevant, and I would say very interesting. So the population of village increases continuously at the rate proportional to the number of its inhabitants present at any time. All right. So rate. So let me explain you the words which are there. The population rate. So population rate is proportional to number of inhabitants, right? So let's say I assume that the population that I'm going to talk about, population I'll talk about P. Then what do you mean by rate? We did it in rate measure. So what is rate of change of population? I would say dp by dt. Let's say population is changing with respect to time with the ratio dp by dt. Now this is given to be proportional to population itself. That is what you meant by the first line. The population of a village increases continuously. So increases continuously at a rate proportional. So this is the rate we are talking. Proportional sign is here, proportionality, to the number of inhabitants present at any time, that is P here. So now if we want to solve this, we know that if you want to remove the proportionality sign, a constant will come, right? So this is K times P, this is given to you. Now this is the equation, right? This is what we need to solve, and it is also given that in 2000 the population of the village in 1999 was 20,000, right? And then this population went to 25,000 in 2004. Then you are asked that what will be the population of the village in the year 2009. Okay, so you can see that here is a difference of 5 years, and again you are asked a difference of 5 years. So do not do this silly error of saying, sir, that this is the difference here of 5,000. I'll just another 5,000 and the answer will be 30,000. You will yourself see that this is wrong, right? Why? Because this is not a linear relation. The rate or the increase of population is not proportional to time. It is something else. So this is the DE that you have formed, right? This is the DE, and this is how the population is changing, and this is how in real life you use DE. So again we'll use the normal stuff, that is I'll put P in one place and K dt at the other place, right? So this is completely variable separable in terms of P and T. So what this will give you, ln P is equal to KT plus C, or I can say P is nothing but e raised to power KT plus C, right? So how many variables or constants, arbitrary constants are there? So the parameters that you need to find here are what? K and C. These are your two parameters, and now you understand that why two conditions were given to you, these 2 year conditions. That is the reason that is two conditions are given, because there are two parameters, so you need P values. How we utilize them, now let's see. So I assume that I start counting from 1999 only. So I assume that this is my initial time period. I'll assume t equal to 0. So at t equal to 0, what is the value of the population? Population is 20,000. Now if I use these two values over here in this particular equation, let me just say this is my major equation, and let me highlight it also, right? So I'll assume this here. So if you use this, what you will get, that this implies P is equal to e raised to power 0 plus C, because t I have taken 0 initial. So why? What do you mean by t equal to 0? That it is the initial from time period, initial time period from where you actually start counting, right? This is what is meant. So what is the value of P? Yes, it is 20,000. 20,000 is equal to e raised to power C. So this gives you the value of C to you, e raised to power C. Okay, now you also need to find K here. So for what is given, that in 2004. So how much time period has elapsed? Yes, 5 years have been elapsed. So T is equal to 5 then, right? So what will happen, and what is the value of P then? P becomes 25,000. So what will be the relation then? 25,000 is equal to e raised to power 5K plus C. And how you can simplify this is that, yes, now students have started to get hold of this one. E raised to power C, you know the value of e raised to power C, just put the value here. So that will be 25,000 is equal to e raised to power 5K into 20,000, right? and from this I can say that e raised to power 5k is nothing but 5 by 4. So now I know the value of e raised to power c and I know e raised to power 5k. So do not immediately pump down and start solving for 5k, and let's see what is the thing which is required. You need to find the value when t is equal to year. Let's say I should not say t, but t is equal to 2009. This implies that t is now 10, because you started counting from when 1999 you assume t equal to 0. So when the year will be 2009, that means how much time has elapsed? 10 years has elapsed. So t is equal to 10. So you need to find the population when t is equal to 10. So what you will do, you will say 10k plus c. What this value will be? Again I can split. So can you see that there is no point of solving for c? You know, you just need to solve e raised to power c here again. Just put the value. So you know e raised to power c is 20,000. Now you need to find e raised to power 10k. What is e raised to power 10k? Can you say e raised to power 10k is nothing but e raised to power 5k square? Yes. Now you can immediately put this value as 25 by 16. Just put this value. This is how you are going to solve this problem. So again, no need to find the value of k here. Okay, I am leaving this part to, and what to leave, you can actually orally calculate. This will come out to be 31250. So this is the population we are looking for, not the 30,000 but 31250. This is how you are going to solve this particular problem. Understand that you were asked to find the values of two parameters, that is k and c in this problem, and for those two data sets were given to you. Okay, now let us take questions which are based on reducible to variable separable, right? Reducible to variable separable, right? So what do you mean by reducible? Though this does not looks like reducible, but leave it. So initially the problem would not be a variable separable form. Initially you will not get a variable separable form, but you can convert this to variable separable by doing some substitution. Yet this could be converted to vs. Let's see how. In this problem you can see that this function is an implicit function, right? This is an implicit function. What do you mean by implicit? That x and y cannot be separated. How you will solve this problem is that I'll take this complete entity as t, right? If I take this complete entity as t, now differentiate, because we need to find the value of dy by dx also. So if I differentiate, this will be 3 plus dy by dx is equal to, and I'll differentiating with respect to x, so this becomes dt by dx. So from here you can say that dy by dx is nothing but dt by dx minus 3. So this entire problem then reduces to new problem. So the new problem that we can now solve is something like this: dt by dx minus 3, nothing but dy by dx being replaced by its value, and this is nothing but t square. Can you see how simple this problem has now become? So this is nothing but t square plus 3, and now it is completely variable separable. You can just say t square plus 3 is equal to dx. This is what the formula for. Now you will integrate, and this formula is nothing but 1 by 2a tan inverse, right? 1 by 2a, that is this particular value, is equal to x plus c. But students, I've seen students committing this error that they leave this here. You were asked dy by dx, that means variables were x and y. Here you have left in t and x, so yes, you will put the value of t again, and that would be your answer. So the answer is nothing but 1 by 2 root 3 tan inverse, what? This complete statement here, 3x plus y minus 1 by root 3 is equal to x plus c. This is the answer we were looking for, and this is how you solve questions which are reducible to vx. Let's take another problem to understand the concept of questions which are reducible to variable separable. So here you can see, now here again this is an implicit function, right? We cannot separate x and y in terms of x and fy. But as we did earlier, we substituted some value to make it in the terms of only t and x. Here, can you see a pattern? What is the pattern? See, the pattern is x minus y, and this is 2x minus 2y. So it is nothing but, can I say that dy by dx is nothing but equal to 2 plus x minus y by 3 plus 2 times x minus y. And what is the pattern then? X minus y is nothing but equal to t. And if I do this, what will this question be reduced to? This will be reduced to something like this again, where I can say dy by dx is equal to 1 minus dt by dx. Now substitute this entire value in the question and see what the new question would look like. So it will be 1 minus dt by dx is equal to 2 plus t upon 3 plus 2t. This is what this question would look like, and this will be dt by dx is equal to 1 minus 2 plus t by 3 plus 2t. And what this will get reduced to then? 3 plus, yes, this will be 1 plus t upon 3 plus 2t. Now can you see that this is completely into variable separable form because there is no term of x. So this actual question then reduces to 3 plus 2t by 1 plus t dt is equal to dx. Now this is the simple question that you have to solve. Okay, and this could be very easily integrated. How you will integrate this? Can you tell me? So, yes, it is nothing but how you can write this as, you can say 2 plus 2t upon 1 plus t plus integral of 1 upon 1 plus t dt is equal to x plus c. And this question becomes what then? 2t plus ln 1 plus modulus t is equal to x plus c. Just put the value of t back in the question. So this becomes 2 into x minus y. I hope now by this time you have got what I meant by reducible to linear variable separable form. Okay, this is how you solve questions which are reducible to variable separable. All right, some examples which you will find is something written like this also. Let's say if this is the question, right? Though I have not taken this question because of the limited time that we people have, but if something of this sort is given, again what you will do, x plus y is equal to 2 in this kind of question as well. Okay, now let's take a problem which is called initial value problem, right? Or in fact, till now we were just solving for general solution, and we'll now solve for a initial value, or you can say a particular solution. That is what is the target now, particular solution. Why? Let's see. So the question given is that you have the equation x minus y. Find the particular solution of the differential equation given by dx plus dy is equal to dx minus dy. At what point? Now this is given to you, so something of this particular condition would definitely be given to find a particular solution. So it is given that y is equal to minus 1 at x equal to 0. So in other way, it can also be given that the curve passes through, whatever will be the curve passes through. These are the two kind of things which actually are given into your question, 0 comma minus 1. So when x is equal to 0, y is minus 1. So if we can convert this into point, this will be x comma y. So it can also be given that the curve passes through 0 comma minus 1, or the value of y is minus 1 at x equal to 0. These are both one and the same thing. So your target is now just to find the equation by using this particular step over here. So what you will do now, collect the terms of dx. So what will be the dx here? If I say dx, so dx will be here, it will come out to be x minus 1, and if I take y here, sorry, so it would be something like this. Let me write again. So x minus y minus 1 dx, right? And this will be what? Plus x minus y plus 1 dy equal to 0. This is what you will get. So what you can say about dy by dx now? So dy by dx would be minus of x minus y minus 1 by x minus y plus 1. So as you can see, it is not directly into the variable separable form, but now we have solved these kind of questions where you can see the pattern is that x minus y is getting repeated in the numerator as well as in the denominator. So if I put x minus y is equal to t here, so what I'll get x minus y dy by dx is equal to dt by dx, or in a way I can say dy by dx is equal to 1 minus dt by dx. So this reduces to 1 minus dt by dx is equal to minus times t minus 1 by t plus 1, right? This is what we can say over here. And if you solve completely, this will be dt by dx is equal to 1 plus t minus 1 by t plus 1. So I'm leaving this now for you people to solve, that how you are going to solve. This is completely a very easy problem now. Okay, so dt by dx is what you people need to solve. Okay, so let's see that we were to solve. So what it will be reduced to that integral of t plus 1 by 2t dt is equal to integral dx. Okay, so I can reduce it to be t plus 1 by t dt, or let's say we'll send 2x over here, 2x plus c. All right, you can say 2x plus 2c, or you can say 2x plus c, one and the same stuff. So this will be what, t plus ln t is equal to 2x plus c. So what will be the value of t that you will substitute? Now you will substitute x minus y plus ln modulus x minus y is equal to 2x plus c. So this is the equation of the curve that was being asked of you. But now if you see that whenever you get a c, that means this is a general solution, right? For this we want a particular solution, one x is equal to 0 and y is equal to 1. So now what you are asked to do is that put the value of x and y that you have got. So put x equal to 0 and y equal to minus 1 and find c. This is how you have to solve this problem. So if you do this, what you will get is 1 plus ln 1 is equal to 0 plus c. C comes out to be 1. So replace the value of c with 1 over here, which will give you the particular solution. So if I just replace this particular value here by 1, so this is the answer that we were looking for. This is the answer now. Okay, so for a particular solution, you will never leave your answer in terms of c. You have to find the value of c. This is how you can interpret a initial value problem or a particular solution problem. Now let us see how do you solve homogeneous equation. That is the second part of how you solve how you solve differential equation. So first of all, what do you mean by homogeneous? So homogeneous equations are of the type where if I want to explain to you in, again, let's say in layman terms, so every term has net power of the variable. Net power, I'll explain what do you mean by net power. Net power of variable constant. Net power of variable as constant. So if I have to take an example, which is the very famous homogeneous equation, that is ax square plus 2hxy plus by square equal to 0. So this is the example of homogeneous equation in two variables, right? This we do in pair of straight lines actually. So why I am calling this as homogeneous? So let me just explain it to you why I am calling this homogeneous. Homo, as the name suggests, you must have done homogeneous mixture and heterogeneous mixture. The same stuff is here. So homogeneous, and I'll explain what is the net power of variable in each term. So let's talk about the first term. It is ax square. What is the variable? X. What is the power here? What is the net degree? 2. Okay. Let's talk about the next term. Next term has 2xy. Variables are x and y. Now assume that each variable is x. How many variables are there? 2. And what is the net power then? X has power 1 and y has power 1, and combined power is 2. Then the next variable is, in the next term is y. What is the power? Square. Again, what is the term? 2. That is why I am calling this as homogeneous. So in fact, you can immediately check from the question itself whether this question belongs to homogeneous or not, because sometimes there is a confusion that when a question is given, it is not very much evident that whether it is a homogeneous form, it is a variable separable form, or whether it's a linear differential equation form. So this is how you can immediately check out whether it is a homogeneous or not. Let's apply this concept on the problem that is at hand. Cube, this is cube, cube, cube. Do not count for dx and dy, right? They are partial derivatives, so we will not count them as the variables. So that means this is completely homogeneous because each term has degree 3, completely homogeneous. So that means this could be solved using the concept of homogeneous. What is the concept of homogeneous? What is the formula or concept of homogeneous equations? That we'll substitute y is equal to xv. If you substitute y equal to xv, then what will become? Dy by dx is equal to v plus what we can say then? X dv by dx. This is what you will substitute, and we'll now try. So for this, what we'll try to form dE in now x and v. Y will be gone, which will be variable separable, right? This is the target of a homogeneous expression. So let's see in this particular question first of all. So if you want to write dy by dx, you can write, otherwise you can directly substitute also, that is not a problem. So this will become what? Minus x cube plus 3 xy square divided by y cube plus 3 x square y. This is what you will get as dy by dx. Now let's substitute y equal to xv here. So this will be what? V plus x dv by dx, and this will be what? Now let's start substituting. The main concept of substituting is that you need to remove this particular y from the equation. So this will be what? X square v square, right? And this will be what? X cube v cube plus 3x square xv. Now can you see that x will cancel out, because x cube here, x cube here, x cube here, and x cube here. So what you will get is 1 plus 3v square divided by v cube plus 3v. So in fact, if you do not get the RHS here, RHS now if you can see reduces to only in v. If you do not get this step, then understand that this is one of the two cases could be there, whether this will not be a DE or you have done a wrong calculation. This should only be in terms of v now. And now if we go ahead and solve it, so what you get? X dv by dx. This v I can send it again here, so this will be what? Minus 1 plus 3v square upon v cube plus 3v, and this will be minus v. And as you can see, now this becomes a complete variable separable form. So now just write by taking the LCM, if I take minus common, so this will be what? V raised to power 4 plus this will be 3v square plus 3v square plus 6v square, right? And this will be plus 1 divided by v cube plus 3v. This is what you will get. And if you cross multiply, so then what we can say? V cube plus 3v divided by v4 plus 6v square plus 1 is equal to, and let's say dv here, and minus dx by x. This is what you will get. And now our only term is left is to integrate this. Okay, so if we integrate, what we can do? V4 plus 6v square plus 1 equal to t, right? This is 4v cube plus 12v dv is equal to dt. This is what you will get, right? And can you now see that this is completely the numerator? Take 4 common, you will get v cube plus 3v dt is equal to dt. So somewhere, never get confused when you see that this is a very big term. You will automatically get very easy calculation, right? This is the rule. So this actually, this entire stuff then becomes what? ln modulus v4 plus 6v square plus 1, and this 1 by 4 will also come out, right? 1 by 4 is equal to minus ln x plus c. And now just replace the value of v. So what is v here? We can say v is y by x. So the answer then that you should finally write is 1 by 4 ln modulus y4 by x4 plus 6y square by x square plus 1 modulus is equal to minus ln x plus c. And then sometimes you will also find cases where this minus ln x plus c can be clubbed with minus ln cx, right? That is also quite possible. Don't worry. Why? Because we can say that c is nothing but minus ln c. Not a problem. A constant can be written in any particular way or any particular shape. You should not be worried about it. And if you again want to completely solve this, now let's completely solve this particular case. So for this, I'll remove this because I need some space on the screen. So what we will get over here is, now we have 1 by 4 ln, and I'll take the LCM here. So it will be y4 plus 6 x square y square plus x raised to power 4 divided by x raised to power 4. And this will be what? Minus ln, and we can say this c can be written as ln cx, right? And this 4 can be sent here. So this can be completely written as something of this sort also. Just check very carefully what I am going to write. So x raised to power 4. This 4 will come here, so it will be minus 4. This can be written something as here. I'm just writing the RHS. Alright. So this will be minus 4 ln cx, which can be written as ln cx raised to power minus 4. And if I remove ln from both sides, this will be c raised to power 4, x raised to power 4, x raised to power 4, x raised to power 4 gets cancelled out. Can you see this now? And if this gets cancelled out, what will be the then next step? 1 by c raised to power 4 again can be written as only c. So the final answer that you can obtain, or that will get matched with your answer sheet, is something of this sort, is equal to c. This is the final answer that might be there in the problem. Okay, so you have to simplify logarithms like this also. You might be possible that you get the answer till here only, but this is one of the things that you should actually understand, that this is how you have to simplify. Okay. Okay, now let's take another question to understand the concept of homogeneous equations. So again, let's first of all immediately check whether this question is homogeneous or not. Okay, the way I have told you. X is the variable. Now cos y by x, you can understand that y by x, the variable gets cancelled out, so this is not a variable. Alright, so I'll not count this as a variable. So now the power of the variable in the first term is only 1. Similarly, I can say in the next term there the power is only 1, because again it is y by x, so both the powers get cancelled out. So again I would say the power is 1, and you have y multiplied, so the net power of each term then becomes 2. Let's check if power of the each or power of the variable in each term on the RHS is also 2, then this is a variable separable form. This is y 1, this is x 1, and this is x 1. So again net power of each term becomes 2. This implies this is homogeneous, right? So at the immediate onset, you can actually check whether the question is a homogeneous equation or not, whether you want to apply the same concept or not. Alright, let me just remove this so that I can have space. Okay, so now for homogeneous, what you will do then? We'll simply put y by x equal to, or v equal to, what you were saying? Yes, y is equal to xv, or we can say y by x equal to v, one and the same thing. And we know that dy by dx then will be replaced by what? Tell me, v plus x dv by dx. So one of the other things that you can do for this particular question to be simplified, first thing that you generally do is that you will write something dy by dx, some function, let's say here, then some function here. I would rather prescribe, rather than let it be like this, f dx is equal to, let's say, g dy. We can solve in this pattern also. For this we need to find the value of partial derivative of dy. What I'll do, I can write this as dy is equal to v dx plus x dv. In a way you understand that you have taken a LCM over here. Okay, but do not do this method in board. In boards you will have to follow this only. Okay, so I'm telling you separately that in boards you have to follow this, or ask your school teacher whether this is allowed in boards or not. Why I'm saying this? Because see, this will make this process very simple. Now start doing the calculations. So this is x, right? This is cos y by x, this becomes cos v. Y is x v, this is sin v, and this is y dx, this is y dx, right? And this is what? Okay, this is y xv sin v minus x cos v, and now this is given to be dy. If you want, okay, let's go by the board method only, because now since boards are near, I don't want you people to get confused much further. Okay, so now this, what you will get here is, let's see, so you will get something of x cos v plus xv sin v multiplied by x into v, right, divided by x v sin v minus x cos v, right? Okay, alright, so this is one more x here, because this is x here, this is x. Now if you can see that here this x and this x gets cancelled out, and in this x, x and x. So the entire problem is dy by dx is equal to cos v plus v sin v divided by v sin v minus cos v. And see this, now this RHS is completely in terms of V. As I told you that if you are not able to solve this in complete terms of V, that means you have done it not correctly. So now just replace the value of dy by dx and this RHS, right? Now as usually that we do, that you have to now solve in terms of x dv by dx is equal to what you will do, cos v plus v sin v divided by v sin v minus cos v and minus v. This is what you need to solve now. Okay, so okay, again an error. This is v also here because v is here. I just forgot to mention it here. Okay, now if you solve this, it could be easily solved. What you will get is that v can be taken common, and if we solve this, you will get what, cos v plus v sin v minus v sin v plus cos v, right, and divided by your same denominator that we were having earlier, v plus right. So if you see this, what you will do, this is get cancelled out, and if I do this, this is completely in the variable separable form. You can write this as v sin v minus cos v, right, divided by v, and this will be what, cos v here, right, cos v. I'll take the 2 here itself, 2 dx by x, and this is dv. Now you need to integrate this. Now how is integrate? We just separate the variables, so you will get tan v dv here minus 1 by v dv, and this is nothing but 2 ln x plus e, and just put the mod. Yes, so this is how you are going to solve this problem. I'm leaving this part for you people to solve. This is completely solvable. You know the integral of tan, you know 1 by v. Just remember to put v is nothing but y by x again in the answer sheet. Okay, let's take another problem to understand the concept of homogeneous equations first of all. So here the term here 1 having no variable, that means power is 0. If we talk about x by y means the power of the variable, net power of the variable, both is 1 and 1, and divide, the power gets subtracted. Again the net power is 0, right? This is also 0. E raised to power xy is 0, 1 0, x by y is 0. That means this is completely homogeneous first of all, right? And in homogeneous, what we used to do, we used to substitute y equal to xv, and this then converts to a problem of variable separable in terms of x and v. That means y was eliminated when we were solving for the variable separable form, right? This is what we used to do generally. But now let's see what is happening in this particular problem. What is the speciality that I have taken this problem over here? Okay, so if I say this particular step, so what was happening, it was y by x equal to v. But can you see here the powers are, what are the powers? Powers are y by x. If you substitute something y by x, you will have to substitute, this is nothing but 1 by v, which is cumbersome, right? So rather than taking v as y by x, what I will do in this particular problem is that I will take x by y equal to v. This implies in a way you are substituting x equal to yv. That means in variable separable form in terms of, yes, y and v only. That means x will be eliminated now. X will be eliminated. You will solve this in terms of v and y. So if I say I'll start differentiating this with respect to y, dx by dy will be, so now remember, now earlier we used to differentiate with respect to x, now you will differentiate with respect to y, and this will become v plus y dv by dy. Now this thing will be used. Now let's rearrange the question that we have at hand in terms of, rather we'll not use dy by dx, but we'll say dx by dy. So if we have to solve for dx by dy, it will be minus e raised to power xy 1 minus x by y, right, divided by, because this term will come here, and this will be 1 plus e raised to power x by y, right? Now let's start substituting the value. So if I use this here, it will be v plus y dv by dy. This will be minus e raised to power v 1 minus v upon 1 plus e raised to power v. This is what you will get, and I can say this is nothing but e raised to power v minus 1 by 1 plus e raised to power v plus y dv by dy. Okay, now if you see the RHS here is completely terms of v, that means our homogeneous step is completely fine, as I told you earlier. So if I solve this further, so this will become y dv by dy is equal to e raised to power v minus 1 plus e raised to power v. This will be minus v, right? Okay, so if we simplify this, what this will then reduce to dv by dy is equal to e raised to power v, that too in minus, and this will be minus v by 1 plus e raised to power v. Now if we separate this into variable separable form, this will be 1 plus e raised to power v upon e raised to power v plus v dv is equal to minus dy by y. Can we say this? And now you can simply see this is very simple to solve. Here if you differentiate the denominator, you will get this particular value. So this is nothing but ln v plus e raised to power v. This is minus ln y plus c. And as I told you earlier, this could be again clubbed to solve minus ln y, and I can say this is minus ln c. And if I take minus common, this comes out to be c times y, right? And this is ln modulus v plus e raised to power vy, and this minus can be taken also inside, and this will become 1 by cy. So the net answer that you people will solve will then look like something this: v plus e raised to power v, right, is equal to 1 by cy, right? And yes, the mod has to be there. Okay, this is what now just put the values of v back. V was nothing but x by y, so this is modulus x by y plus e raised to power x by y is equal to 1 by cy. Whichever answer, because this will have two answers, plus and minus, this is the answer we were looking for, and this is how you solve problems based on homogeneous equations. So just do not go by the learned formula that every time we'll replace y equal to xv. We can also do x equal to vy whenever it is required. Okay, that is why this problem was taken. Okay, students, so we'll be doing stopping our class for today here, and we'll be beginning our class tomorrow with linear differential equation, and that is another very important topic that we'll cover, and we'll finish this topic in tomorrow's lecture. As usual, I'll be sending you the worksheets. In fact, if you want to practice this chapter, you can start doing your NCERT, because this will help you in both the ways. It will prepare you for your boards as well as for your JEE Mains. The NCERT for this particular chapter is brilliant. Just start solving it. In fact, this is one of the best books for your base development for this particular topic. And apart from the NCERT, you can just solve the worksheets, and guess that is the more than sufficient that you can do at this point of time. Alright, for NCERT solutions, as usual, just go and check out our channel. Okay, so that's it for today. Meet you tomorrow with lecture 2 of this particular chapter. Good night.